One or two folks have been in touch and asked about Chapter 54. They've noticed that there are many tables in this part of the book, all to do with earthing arrangements and protective conductors. This has left some people a little confused, so in this video we'll try and straighten a few things out and give you some good tips to help with your 18th edition exam. And, as usual, there will be questions for you to attempt yourself at the end, with answers. Before we begin, we need to explain a very important point. The purpose of the 18th edition exam is not to assess how much you can remember, but rather it is to determine if you can find the answers to the exam questions in the wiring regulations book. And there's a big difference. To pass the exam with good marks, it's essential that you can find your way around the book and home in on where the answers will be. You can't remember every page of a 600-page book, but you can learn how to use the book, and that's what counts. And all references in this video relate to the Brown 18th edition Wiring Regulations Amendment 2 book. In the 18th edition BS 7671 exam, there will always be questions on Chapter 54, which is about earthing arrangements and protective conductors. Every exam will have these questions. Learn how to find Chapter 54 and the correct tables quickly and easily. We can start with a recap on the different protective and earthing conductor names as they apply to domestic installations and others. Beginning on the left, we have the earthing conductor from the cutout box of the installation to the consumer unit. Shown here is a TNCS system, but it could just as easily be a TNS or a TT system if we added an earth electrode. Next, on the right, is a main bonding conductor, if required, going to the incoming metallic water, gas and oil services. We have some socket outlets with their associated CPCs or circuit protective conductors. Then we have supplementary bonding conductors that may need to be installed in special locations or other higher risk areas. Note that supplementary bonding connects, in this example, the tap to the radiator, but we've also connected the radiator to the earth or CPC of the socket outlet. This could have been the shower CPC or the shaver socket CPC. The supplementary bonding needs a path back to the consumer unit, but it does not go back directly itself. Instead, it connects to a local electrical appliance and uses that appliance's CPC for its return path. Before we move on, be aware that earthing is not bonding and bonding is not earthing. They are two totally different methods of achieving electrical safety. Earthing reduces the risk of electric shock to persons or animals and limits equipment damage by providing a low resistance earth path for fault currents. If the earth path is of sufficiently low impedance, the fuse or breaker will disconnect the supply, whereas bonding prevents potential differences or voltages from developing between metallic parts and thereby reducing the likelihood of an electric shock when touching two different metallic parts. It equalises any potential differences. This little chart will help to put the right names to the right conductors. Pause the video for a moment and make sure you understand it. We begin with earthing conductors and Table 54.1. What is the minimum size CSA of a buried earthing conductor? Turning to page 198, we have Table 54.1, minimum cross-sectional area of a buried earthing conductor. The key words to look for in an exam question are buried earthing conductor. That will put you onto the correct table. We can show how the table works with a typical exam question. The question asks, what is the minimum cross-sectional area for a buried copper earthing conductor that is not protected against mechanical damage and is not protected against corrosion? If you're on the correct table, Table 54.1, then finding the answer could not be easier. All the clues are in the question. Find the row, not protected against corrosion. Find the column, not protected against mechanical damage. And where the row and column cross is the answer. The question tells us it is a copper conductor, and there is our answer, 25 square millimeters. Another question now. Where PME conditions apply, an earthing conductor shall meet the requirements of, and a list of 4 potential regulations. A very helpful clue to finding an answer is that the question is about earthing conductors, and there is a good chance that the answer will be close to the table that we've just used. This can help in an exam. And just above table 54.1 we find our answer in regulation 542.3.1. It tells us that where PME conditions apply, an earthing conductor shall meet the requirements of regulation 544.1.1. So we should choose answer C, regulation 544.1.1. Now we can look at protective conductors, circuit protective conductors and CPCs. This section is about the adiabatic equation, and it is almost certain that you will have a question on this in any 18th edition exam. What does the word adiabatic mean? This is a thermodynamic process in which heat neither enters nor leaves a system, a closed system. For a conductor, we are assuming that the conductor heats up because of the current flowing through it, and none of the heat escapes into the outside world, nor does any heat from the outside world enter the conductor. In other words, all the heat is retained, the worst case scenario, and this is what we plan and design for. But in reality, some heat will be lost into the surrounding environment. But if the worst case passes, then some heat loss only makes our situation better. Look at page 199, where the adiabatic equation is shown, and what the symbols mean is shown below, and these can also come up in an exam question. In an exam, you will be given all the information that you need. After all, you only have 2 minutes per question, so read the question carefully. It's all there. Note, only the top half of the equation is square rooted, not the whole thing. If you are using a calculator, you can follow a sequence of data entry. Calculate I squared first, then multiply by t, then square root, and finally divide by k. Enter it into the calculator as shown in the blue box. This sequence works for most calculators, but some have a slightly different sequence. Check and practice with the actual calculator that you will use in the exam, and do this before the exam. Alternatively, break the calculation down into easier chunks and write out your workings. I often do. And it must be a standalone basic calculator. You will not be allowed to use the calculator function on a mobile phone in the exam. Let's work through this question using the adiabatic equation. What is the minimum CSA or S for a copper protective conductor if 750 amps of fault current will flow and the protective device operates in 0.4 seconds? And we will take K to be 115 from table 54.3 on page 200. We have 4 answer choices, all standard cable sizes. We must choose a cable size equal to or greater than our calculated answer. Here's the adiabatic equation with the numbers in place. The green box shows how we might put this into a calculator. Our answer is 4.12 square millimeters, and we must choose a size equal to or greater than this, not less. We should choose 6 square millimeter conductor, answer C. Do not be tempted to choose 4 square millimeter just because it is close to 4. In the exam, we work to exactly what the regs book tells us, equal to or greater than, by even the tiniest amount. A question that often pops up: is it square millimeters or millimeters squared? Is there a difference between them? For conductor CSA, we pronounce it square millimeters. How many single millimeter squares will cover the cut end of the conductor? Let's use 10 square millimeter conductor as an example. 10 square millimeters means that 10 individual millimeter squares would fit on this circle, which is just less than 4 mm in diameter. So we have 10 by 1 mm squares. But 10 mm squared makes this surface equal to 100 individual millimeter squares, and a circle of almost 12 mm diameter, 10 by 10 or 100 1 mm squares, and you won't fit that in the earth bar. We can also use a table to find the CSA of a protective conductor, what we call a tabulated CSA. Look at table 54.7 on page 201. A question may ask you to find the tabulated value for the minimum cross-sectional area of a protective conductor. This time, the line conductor size will determine the protective conductor size. If the exam question asks for a tabulated value and only provides a CSA for the line conductor, then this is the table to use. It's a popular table for exam questions, so make sure that you can find it. In table 54.7, S is the size or CSA of the line conductor. There are 3 size options in the table, and we will look at each one in turn. You must understand what they mean. Looking at the first row, we have S is equal to or less than 16 square millimeters, which fits with most domestic cables. If S, the line conductor, is equal to or less than 16 square millimeters, then the protective conductor is the same cross-sectional area as S, the line conductor. If the line is 2.5 square millimeters, then the earth or CPC should also be a minimum of 2.5 square millimeters. If the line is 10 square millimeters, then the earth or CPC will also be 10 square millimeters as a minimum, and that's all that there is to it. The next row shows that S, the line conductor size, is more than 16 square millimeters and equal to or less than 35 square millimeters. Reading the column for this size line conductor, it tells us that if S, the line conductor, is more than 16 square millimeters and less than or equal to 35 square millimeters, then the protective conductor should be 16 square millimeters. No other size choices, just 16 square millimeters. And finally, the third row where S is greater than 35 square millimeters. If S, the line conductor, is more than 35 square millimeters, then the protective conductor should be half the size of S, as shown here. If the line is 50 square millimeters, then the earth or CPC should be 25 square millimeters. Moving on to another table, main bonding CSA in relation to the pen conductor CSA. A pen conductor relates to TNCS systems. The protective earth and the neutral are combined in the incoming service cable. This is table 54.8 on page 205 and is an easy table to use. Decide on the CSA of the pen conductor and select the CSA for the main bonding conductors to the gas and oil, etc. As before, we have a question to demonstrate this. What is the minimum cross-sectional area of a main protective bonding conductor if the cross-sectional area of the pen conductor is 25 square millimeters? If you are looking at the correct table, then nothing could be easier. 25 square millimeters is less than 35 square millimeters, so we need the top row. Move to the right column and read off the answer. Our main bonding should be a minimum of 10 square millimeters. Next is supplementary bonding conductors, and this always causes some confusion. Let's make it easy to follow. We are looking at section 544.2 on page 205. No tables on this page, just words. Most times there are just 2 sizes of supplementary bonding conductors that we are interested in, either 2.5 square millimeter and 4 square millimeter. Plus, we need to consider exposed conductive parts and extraneous conductive parts. An exposed conductive part is a conductive part of the electrical installation which can be touched in use. It is not normally live, but can become live during a fault. Think of the metallic casing to a fluorescent luminaire. In fault-free, everyday use, the casing is not live and can be touched as often as you like without danger of electric shock. But during a fault, say a loose wire, the casing can become live. If the casing is touched, an electric shock may result. So, we supplementary bond the casing back to earth so that a fault will cause the fuse to blow and make the circuit safe. An extraneous conductive part does not form part of the electrical system, but may introduce a potential, usually earth potential. This can become a shock hazard during an electrical fault. Think of touching the central heating radiator and the water tap if there is a potential difference between them. Connecting them together reduces the shock risk. Page 206 of the Brown Regs book has several regulations showing supplementary bonding conductor sizes, but the information is hidden in the text. The table shown here gives a quick breakdown of the information contained in these regulations. You should notice that the three regulations cover the combinations of bonding exposed to exposed parts, exposed to extraneous parts, and extraneous to extraneous parts. Pause the video and take a moment to follow the table. Let's have a question. A copper supplementary bonding conductor is to be chosen. It will connect two extraneous parts together and will not be provided with mechanical protection. What is the minimum cross-sectional area of the conductor? A simple enough answer. Find the row for extraneous to extraneous, find the column for no mechanical protection, and where they cross is the answer 4 square millimeters. But of course, you will not have this table in the exam, so learn how to find the regulations, learn how to interpret them, learn how to use the book. It's over to you now. 10 easy questions on what we've just covered in the video. Get to grips with these and you will be improving your pass mark in the exam. Pause the video at each question and attempt an answer, and as usual, answers at the end. Question 1 asks, a buried earthing conductor is to be installed. The copper conductor will be protected against corrosion but not protected against mechanical damage. Select a suitable cross-sectional area for the conductor from the 4 sizes offered. Pause the video and find an answer. Remember to write your answer down. My answers are at the end. Question 2 next. Use the adiabatic equation to calculate the minimum cross-sectional area of a protective conductor using the following data. I equals 380 amps, T equals 5 seconds, and K is 143. Then select a suitable conductor size. Pause the video while you calculate the answer. Question 3 asks, what is the tabulated size of a protective conductor if the associated line conductor has a cross-sectional area of 100 square millimeters? Pause the video, find the answer, write it down. Question 4 is another calculation. Choose the correct answer from the 4 choices. On to question 5 about supplementary bonding conductors. Pause the video and find the answer. Question 6. What size copper protective conductor should be selected if a fault current of 680 amps might flow with a required disconnection time of 0.4 seconds and a K value of 115? All the information you need is in the question. Question 7 next. For comparison of how disconnection times can affect the size of the conductor, have a go at this question. The previous example had a disconnection time of 0.4 seconds. What minimum CSA would the conductor be if the disconnection time was 5 seconds? Use the following data. I equals 680 amps, T equals 5 seconds, K equals 115. Only T for time has changed. Question 8 asks us to determine the minimum CSA of a main protective bonding conductor if the pen conductor of the supply is 50 square millimeters. Pause the video, find the table, find the answer and write it down. Question 9 should be easy if you use the correct table. Pause the video and choose an answer. And last but not least, question 10. Which of the below formulas represents the adiabatic equation as used in chapter 54 of the wiring regulations? And here are the answers and where to find them. There will always be questions on chapter 54 in an exam, and understanding how the tables work will help. Make sure that you can use the adiabatic equation. It often comes up in an exam. Thank you for watching. It really is appreciated, and I hope that you found this video useful, informative and helpful in your exam preparation. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. And don't forget, you can type in LearnElectrics into the YouTube search bar to go directly to our channel at any time from any computer or smart device. We are always adding new videos to our channel, so don't miss the next one. And once again, thank you for watching, and we hope to see you again very soon.